This video will overview the basic concepts of RF4CE, why and when you want to use RF4CE, key terminology, pairing sequences, and topology will all be discussed. What is RF4CE? Radio frequency for consumer electronics, as indicated by the name, was specifically designed to work for consumer electronics. In most cases, these electronics are remote control-based networks such as TV remotes connected to either a set-top box or a TV. The RF4CE stack is a networking application layer built on top of the IEEE 802.15.4 standard in the 2.4 GHz frequency band. This is similar to the ZigBee Pro stack that Silicon Labs offers. The topology of the RF4CE stack is a multiple star network topology. This means that it does not use a mesh networking routing system. All communication in the network is handled through either broadcasts or unicasts that use different levels of optional security. These options include MAC level acknowledgement and/or network level security. This leads to an important question of when it is pertinent to use RF4CE. Since RF4CE does not rely on IR communication, the communication can be handled in a robust network that does not rely on line of sight. This allows for easier two-way communication between a remote and target device, which creates a better customer experience for standard remote control operations. The flexibility of optional MAC level acknowledgement and network level security allows for each network to use different levels of security based on their needs. The main use of these security measures are to block against replay attacks and malicious eavesdropping. Finally, there are mechanisms in place to ensure long battery life, such as frequency agility and standard power saving mechanisms. Power saving and security will be further discussed in a video focused around more advanced RF4CE topics. There are a few key terms that are important when trying to understand the RF4CE protocol. These terms are originator, recipient, controller, and target. An originator and a recipient are very simple and complementary terms. The originator is a device from which a transmission is sent, while the recipient is a device to which a transmission is received. A controller and a target are also complementary terms, where the controller is a network participant with ZigBee RF4CE functionality. As a participant, it must join an existing network in order to talk to other nodes, and it is often an originator, but not always an originator. The target, being complementary to the controller, is the device that creates the network and is a coordinator with ZigBee RF4CE functionality. While a target needs to create a network, it also may join a network created by a different target. A target is often a recipient, but not always. An example of this would be a set-top box creates a network and a TV joins it. The set-top box would be the originator to the TV and a recipient to the set-top box's remote. Network formation has a couple of steps. The first step is discovery. To begin discovery, first, an identifying process begins where targets within radio range are detected. At that point, the originator initiates the discovery process. Normally, the originator is a controller, but can also be a target. The discovery requests are transmitted to a particular group, which can be either all the nodes in a particular network, or a specific node. The request will contain information about the originator. This information can be capabilities, vendor information, or device type preferences. For example, it may contain the information that it is a multifunction remote control attempting to discover a TV. This process will repeat until an application or profile-specific condition is satisfied, such as a certain amount of attempts or time passed. On the target side, automatic discovery can be enabled, where a target will send discovery responses to the originator's discovery request. After the discovery portion of network discovery, the pairing process will take place. It is also important to note that using a different out-of-band pairing method, such as unique per-device code, you can skip the discovery process and move directly to the pairing process. The pairing process is the forming of bidirectional links between two devices. While the pairing sender can be either a target or a controller, the recipient of the pairing must be a target. During this step, The pair request will include the originator's information in a similar fashion to how the discovery request includes the originator's information. In response to the pairing request, a pair response will indicate either success or failure. If it is successful, a key exchange will begin, followed up by a pairing table setup, a pairing reference message and exchange. The pairing references are messages designed to assign unique references for each device, which the stack will use by associating them with network addresses. As previously mentioned, the topology of RF4CE is a multi-star network topology. As an example, in the diagram, excluding the optional gateway, we see 3 different networks formed with one target and one remote controller. Each of these networks are connected by a multifunction remote, which can connect to the target in each network, making a large star network. Keep in mind that even though it connects to one large network through the multifunctional remote controller, RF4CE networks do not do any multi-hop routing. The final part of the topology is that a gateway can join the network and connect to a target. As a requirement, each controller must have space to connect to one device, while each target must have at least 5. This concludes the basic concepts for RF4CE. For more details, please review any other RF4CE concepts videos or the UG 10310 App Dev Fundamentals RF4CE document. Thank you for watching.